Understanding congruence and line segments. A line segment is a part of a line that is bounded by two endpoints. Unlike a line, which extends infinitely in both directions, a line segment has a fixed length that can be measured. The concept of congruence in geometry plays a crucial role in proving various theorems and properties related to shapes, angles, and triangles. To determine which line segment is congruent to ST, we rely on one or more of the following conditions: equal length. Two line segments are congruent if they have the same length. If we are given a diagram or problem where the length of ST is explicitly mentioned, then any other segment with the same numerical length is congruent to ST. Tick marks or notation in a diagram. Often, in a geometric diagram, congruent segments are marked with identical tick marks. If another segment, such as UV, has the same tick marks as ST, then we can conclude that Saint UV Cong UV given or proved by theorem. Sometimes, a problem may state explicitly that two segments are congruent. This can be based on given information, or it can be derived from a geometric theorem, such as the midpoint theorem or triangle congruence postulates, for example, SSS, SAS, ASA. Examples of congruent segments to solidify our understanding. Let's explore different ways to determine congruent segments. Direct measurement. Suppose we are given that Saint equals 5 equals 5 units and another segment AB is also measured to be 5 units. Then, we can conclude. Street ABST Cong ABST of congruent triangles. If ST, a side of a triangle and another triangle is congruent to the first triangle by criteria such as SSS or SAS, then the corresponding side in the second triangle will also be congruent to ST. Midpoints and bisectors. If a line segment is bisected by another line, it is divided into two congruent segments. For instance, if MMM is the midpoint of ST, then we can say SMMTSM, CongMTS amount. This is because a midpoint divides a segment into two equal parts. Parallel lines and transversals. In some cases, congruent segments appear in figures with parallel lines. If two parallel lines are cut by a transversal, and if specific conditions hold, we may find congruent segments. For instance, if a transversal bisects two parallel lines at equal distances, the segments it creates on each line are congruent. Applying the concept to real-world problems, congruent line segments are not just an abstract concept. They appear frequently in engineering, architecture, and design. For example, in construction, ensuring beams or supporting rods have equal lengths is essential for stability. In graphic design, symmetrical patterns often rely on congruent segments to maintain balance. In navigation and mapping, congruent segments help in triangulating distances and ensuring accurate measurements. Conclusion. In summary, the line segment ST is congruent to any other line segment that has the same length.